Okay, today's new lecture, and the lecture is on analysis of grades. And I've already explained that what grades are. Grades are actually is a structure whose members are lying in x and z axis, and there is no axis or no member in y axis. However, the loading is essentially in y axis. So, I mean, the grade given is here. I mean, this is a grade, and one of the axis is one of the member is in x-axis, and the other member is in z-axis. So you should know that this is my y, and this is my z, and this is my x. Okay, let me change the color of the pen because okay. So, loading is always in y-axis. You can see the loads are in y-axis in on both the members. Okay, and you should know that as the loading is in y-axis, and here the loading is also in y-axis. One of the member is in x-axis, the other member is in z-axis. Loading is in y-axis. Okay, so when load is in y-axis and member is in x-axis, then the moment form would be in z-axis. So this is mz. Also, when load is in y-axis and the member is in z-axis, then the moment would be in mx or in x-axis. It means these two equations are valid for grades, and you can recall the first two lectures. I mean, you should go back and find the number of compatibility equations valid for grades. Also, the loading is in y-axis, so summation of forces in y-axis should be equal to 0. Summation of mx, as proved here, should be equal to 0, and summation of mz should be equal to 0. It means there are three equations valid for this structure. Great. It means we have the generic formula for grades. SI of the grade is this m plus r minus j. But you know, per member there are three unknowns. What three unknowns are? mz, mx, and shear in y or fy. So that's why I have 3 here, and I have 3j as well, because at any joint 3 equations are valid. So I am iterating again and again so that it is recalled, and it should be recalled strongly in your minds. Okay, I found it, and it is because it has two member, one member and two member. So this is 2, and we have one joint and two joint and three joint, so it is 3 here. So it comes out to be 3 degree. It means this grade is statically indeterminate to 3 degree. It means it has 3 extra reactions, or it should have 3 redundant actions. So I have to remove one of the supports to make it redundant. Actually, you should know that in this grade, I mean the loading is there. So this grade, the fixed support shall develop this reaction and this moment. Also a moment here would be developed. And also here, yeah, 3 reactions. The moment in z direction, x direction, the moment is in z direction. So in grades, there are 3 reactions at fixed support. What if the grade is like this? So when grade is like this, so it should have only one reaction. But there may be some case that supports are capable of resisting torsion, but that is very advanced case. You should, I mean, stick to only this. And what if a grade has only a roller support and this hinge support? For example, let me draw it very clearly. Suppose I have a grade, and the grade has fixed support like this, and one hinge and one roller. Then vertical, the moment in x, the moment in z. Here only vertical, Here only vertical, here no reaction. So grid should be recalled. Okay, I have made it determinate by exposing 3 reactions. I have just omitted this support and 3 reactions are exposed now. So these are my redundant actions. So I'll apply one by one these reactions. I'll construct a moment table. I'll also construct a moment table under original or applied loading. For example, this is my first step. Construct moment table for grid under applied loading. Okay, this is very important. I mean, I've left this space so that I can do some calculations here. So I have this grid. Okay, this has a load of 2 kip per foot, and I think I should draw it here. This is actually a free body diagram, so let me draw it on open board so that it is clear. Let me try. For example, if I want to draw here and I want to know whether it's working fine here or not. This is my pen, so okay. For example, this was my support. Okay, and this was my 2 kip per foot load. So this 2 kip per foot is acting for 20 feet, so it would be balanced here. So 2 into 20 gives us 40 kips, and then this 40 kip would be balanced here, and then this 40 kip would be balanced here. I have balanced this joint. Okay, one more thing. This is in y, 2 kip per foot is in y-axis. This member is in z-axis. So y z combination gives us x. A moment shall form in x-axis. So if you rotate this load towards this joint, which is B, it forms a clockwise moment. So I have to apply a resistive anti-clockwise in x. This is mx, and its magnitude should be equal to 2 into 20 into 10. 2 into 20 into 10. It comes out to be 400 kip foot. And this joint has to be balanced, so I have balanced this here. Again 400 kip foot. And again this would be balanced here. Every joint has to be balanced, like this joint has been balanced. Every member has to be balanced. Again, I have 10 kip here as well, upwards. So this should be balanced here with 10 kip. So 40 plus 10 gives us 50 kip. So here the load would be 50 kips. Again, you should calculate. This is in y-axis. This is also in y-axis. This is 15 feet. This is 5 feet. So here the moment should be there because these are y, and this is x. So there would be a moment here. So that moment, the magnitude of the moment, 40 into this distance is 15 plus 10 into 5. So it comes out to be about 700 about kip foot. So this would be 700 kip foot. So you can see that this moment 700 kip foot is formed as a result of this 10 kip. For example, it is very easy to find this 700 kip foot. Let me find it again for you. For example, here. So I suppose that it is anti-clockwise and it is mc. Okay, so moment here would be equal to mc plus 10. The distance here is 10 feet and this distance is 5 feet. So 10 into 10 and 40 into 15. 40 into 15. So it comes out to be mz plus 700 kilofoot. I have assumed it as anti-clockwise, so I'll apply a minus sign here. So mz would be equal to 700 kilofoot. Now my answer is plus. It means my assumed direction was correct. I initially assumed it to be anti-clockwise. And the final answer is plus. It means it's affirmation that your assumed direction is correct. So you have to practice this. These are very basic concepts that were taught to you in your BSc, but unfortunately you were not very serious at that time. Okay, finally, maybe some of you have the idea, but I believe most of the people may suffer or may find it a problem. Okay, finally, I have this x-axis. I have because there is an intermediate load here, so I have made one section here, one section here. The origin is A. Here the origin is B. Here the origin is C. So for A, you can know, I mean, I have to find all moments here. So I have to find all moments here. This 700 foot is a pure moments, and this is anti-clockwise. So it would be plus 700 under mz because this moment is in mz. Also, this is in y and this member is in x. So y-x combination z gives us a moment in z. If I rotate here, it forms a clockwise moment. 50 into x, resistive would be minus 50x. So I obtained this. Similarly, under tx, you may know that this is a torsion because this is x-axis. So this is a torsion in x direction. It would be balanced here with equal and opposite. You know this is positive? Yes, it is positive. That's why I have written a 400 here. Member BD, this is your B. The origin is B, you have to find all moments here. This 40 is forming a moment because this is y, this is x, so 40x would be a moment clockwise. Clock. It should be balanced with resistive minus 40x. And this moment should be in C because load is in y and member is in x. Okay, this is a torsion in x direction. This is plus, this is clockwise. It would be balanced here with anti-clockwise. So I'll write a minus 400. Finally, the final member is this. And I have to find all moments here. The load is in y-axis and member is in z-axis. So it is forming a clockwise moment. So resistive would be minus 2 into z by 2 minus z square. So the moment table has been constructed easily. Okay, finally, now the moment table has been constructed and I have to apply a redundant actions one by one. So to apply a redundant action, first redundant action, for example this, I have applied this one kip and you know this is 20 feet. It would be balanced here with one kip. It is forming an anti-clockwise moment. So balance would be, I have to balance it with a clockwise moment, 20 kip foot. This joint has to be balanced, so I'll balance it here. I'll balance it here. I've done here. Okay, this joint has to be balanced in terms of loads. 1 kip and 1 kip. Finally, this is forming y. This is x. This is x. This is y. Z. There would be a moment in z. This is forming an anti-clockwise. This would be clockwise. Clockwise. This is 15 feet. So this would be 15 kip foot. You can see. It's very easy. So I have drawn the free body diagram. Here a table has been constructed for AR1 is equal to 1. For member BC it is comes out to be Z. For member BC it comes out to be Z plus Z. How? Because this is member BC and I have to find all moments here. This is forming an anti-clockwise moment. If you rotate this one cap in this direction, it would be anti-clockwise minus Z. The resistive would be plus Z. This is Y, this is Z. The moment should be under mx. And you can see here, it is the moment under mx. Okay, I shall go for BD. X and 20, it is under mz and tx. Here I have to find all moments here. So you should know that this is a pure torsion. This is minus. So there would be, this is in x direction. So this is minus, so the resistive would be minus 20 plus 20 because this is anti-clockwise and minus. So it would be balanced with equal and opposite. Also, it is forming an anti-clockwise moment. Y, X combination is Z. It is forming an anti-clockwise moment. Resistive would be clockwise. X. So you can do it for yourself. It is very easy. Let me draw this. I mean, this is very easy. Oh, okay. I have to apply it. I mean, let me draw it again because it is being balanced here. Okay, I have applied a unit return action here. It is balanced here, balance here, and you have to balance equal and opposite. Okay, and you know that this is A and this is your B and this is your C. Mara kya zulam ho gaya.